Zoonotic diseases from wildlife are a huge risk to human and domestic animal health. Diseases can be difficult to maintain and identify as they have the ability to appear and disappear, and this has become a noticeable key aspect on the studies of the spread of Hendra virus through large bat colonies. Many previous studies of Hendra virus hypothesized that the transmission of the virus was transferred via urine when the colony was migrating. There has always been flaws in this theory, and a recent study undertaken by Kung and associates explored the ideals that Hendra virus occurs via latency and recrudescence. According to Farlex, recrudescence is the recurrence of a pathological process or its symptoms after a period of improvement or silences. This can be seen in malaria outbreaks, as parasites can be notoriously difficult to completely eradicate from the human immune system. Recrudescence can often be confused with reinfection, but in fact it is not, as the infection never leaves the immune system. It only represses until the immune system is weak enough for the infection to take hold again. In order to test the theory of recrudescence, a single isolated colony of grey-headed flying foxes were monitored. This colony included bats of all developmental stages and sex. This made up a population of approximately 10,000 bats. It was first noticed when the results were gathered from the fieldwork that the primary factor limiting infections was the number of susceptible individuals rather than the number of infectious individuals. Once the number of vulnerable flying foxes decreased, local viral extinction increased. Given these results, it was concluded that the pathogens could not sustain itself within the host population if the proportion of susceptible bats were less than 0.2 at the time of invasion. It was noted that pregnancy and lactation were significant risk factors for neutralizing antibodies to Hendra virus, therefore making it a higher risk to female individuals than male. This graph displays a clear view of the effects of Hendra virus within a population. According to the information gathered, a smaller colony of around 5,000 individuals will result in an epidemic of Hendra virus that isn't as high of a magnitude than a larger population of around 10 to 15,000. But the duration of the epidemic will be longer, as shown in the top of this graph. The graph also tells us that if the number of recrudescent individuals is around 0.95, there will be no effects on the colony. But supporting evidence to recrudescence has been observed in bat colonies around the world. One of these cases was observed by Pete et al., who reported herpesvirus findings in fruit bats on an isolated island in the Gulf of Ghana. His findings supported viral recrudescence. It is imperative that further investigation into the spread of Hendra virus is explored. Additional field observations should be carried out to test this hypothesis. This could be achieved by looking at multiple bat colonies within close proximity, especially around peak times of the year, which were noted to be around the months of June through to August when pups are being born. If recrudescence was seen to be a mechanism of the persistence of Hendra virus, scientists could work on a way in which to stop these reoccurrences happening, with the long-term goal of completely eradicating Hendra virus from bat colonies.